We are going to discuss IP addressing and subnetting in this visuals. Well, networking means connecting devices with each other so that communication can be established between these devices. Well, the question arises that these devices can communicate with each other, but how these devices are identified? Well, in real life, we are persons identified by our names. In networking world, devices are identified by IP addresses. IP means Internet Protocol. There are two versions of IP. There is IP version 4 and IP version 6. We will discuss IP version 4, subnetting, summarization, CIDR, etc. In short, we are going to discuss IP version 4 in complete detail. But as far as IP version 6 is concerned, the basics of IP version 6 is discussed under CCNA. We are going to discuss IP version 4 in detail in this visuals. We will discuss IP version 6 in later visuals. So let's start our discussion. Now, well, IP version 4 addresses are in decimal form, consist of 4 octets. 1, 2, 3, 4. Now, as you can see these 4 octets, each octet represents 8 bits. 4 octets with 8 bits each provides 32 bits in total. Now, we will discuss all these octets with complete detail later in the same visuals. Well, there are different range of addresses under IP version 4. Let's look at IP version 4's different address range. Now there are, well, at the top here it is public address range. Now public address range is used for internet. You can see class A, then class B, and then class C. Public address range. These all public IP addresses are used for internet. There are 4 RIR, Regional Internet Registries, which provide these public IP addresses to different regions of the world. These regional internet registries are maintained by IANA, Internet Assigned Numbers Authority. Now, this is how public addresses are distributed to the whole world. After that, we will discuss private range. Now, as you can see, there are reserved IP addresses for class A, class B, here it is, and class C, here it is. Now, these IP addresses range is considered as private address range. These private IP addresses are used for local networking. Well, for example, I am creating a networking of 100 hosts. To identify these hosts on this private network which I am creating right now, I will use private IP addresses. It is my choice whether I use class A, class B, or class C's private address range, and it depends on the size. We are going to discuss all this a bit later. Now let's move towards loopback address range. Well, these addresses are used to check the TCP/IP implementation on the local computers. These addresses are not used for networking purposes. Now we have discussed public range, private range, loopback address range. Now here it is, we are going to discuss multicast range. Here now, this address range is reserved for multicast. I explained you multicast process in our previous visuals. The last topic for this presentation, here it is, reserved range. This range of IP addresses is reserved for future use or experimental purposes. Now with this, let's get into more detail of IP version 4 range. Here you can see classful subnet masks and classless subnet masks. We're going to discuss all starting from classful subnet masks. Now we have discussed private addresses of class A, class B and class C. These are the default subnet masks for class A, class B and class C. Well, when these reserved private addresses used with its default subnet masks, like here it is now, like class A's private address range as a whole with its default subnet mask, class B's private address range as a whole with its default subnet mask, and class C's private address range as a whole with its default subnet mask. These all considered as classful address range. It is simple, as you can see. Now let's move towards classless subnet masks. Now when we use these private IP addresses by not following the way of classful address range, like we use class A private address range but we use them in between this classful address range, like here you can see 10.10.10.1.0 with its default subnet mask, and 10.11.2.0 with the subnet mask, and 10.9.1.0 and so on. Well, this will be known as classless address range. Well, there is a reason of using classless address range. These classful addresses provides more than our required addresses. Like class A classful address range provides thousands and millions of addresses. This is the reason we do not follow classful address range. Now we can also use class A addresses with class C subnet mask and class B addresses with class C subnet mask and etc. Now moving towards important points. Now by breaking the classful address range we got classless address range. Now by breaking classless address range we produce address range according to nearly our required addresses. Well, this breaking of classless addresses is known as VLSM, means virtual length subnet mask. Well, usually classless and VLSM are treated separately, but I consider both these terms, classless and VLSM, as single term because we get into classless address range and then we produce VLSM. Well, virtual length subnet masks will be discussed in complete detail. Well, this is the term which has the importance of backbone for CCNA and above courses. Well, as I said a bit earlier that we can also use class A addresses with class C subnet mask and class B addresses with class C subnet mask and etc. Well, because this is the subnet mask which decides how many hosts will be provided, not the address ranges. Well, apart from default subnet mask, there are custom subnet masks. As you can see, these are custom subnet masks. These all are. Well, now these are the subnet masks which are used, thus came with VLSM. Well, this is the whole process which we will discuss and understand completely. These are the things which we have to expert of. We will start discussing subnetting a bit shortly. Now we are moving towards CIDR. It means classless inter-domain routing. Well, we were discussing that this is the subnet mask which decides that how many hosts will be provided. Well, there are three default subnet masks for class A, class B and class C. You can see these top three default subnet masks. This is the list of all subnet masks. How we came with these subnet masks? Well, there are 4 octets for a subnet mask. Each octet consists of 8 bits. These bits position describe the subnet masks. As you can see, these values 8, 9, 10, etc. These are the bits describing the subnet mask. We are going to discuss subnetting, doing subnetting and creating virtual length subnet masks is considered as advanced form. Well, we do not use these terms class A, class B and class C. We recognize these subnets by these bits. Well, these are the prefix which describes the network. We use prefix like /8, /9, /10, 11 and etc. Well, to describe a network. Well, this whole process is known as classless interdomain routing. Now we are moving towards rules for subnetting. Now we are going to start subnetting. Well, I have mentioned before that this is the subnet mask which decides how many addresses are to be provided. I also mentioned that it is the bits which describes the subnet mask. In simple, we are going to play with these bits, and this game playing with bits is known as subnetting. Well, you can see these 4 octets. There are 3 terms with 4th octet. Actually, these 3 terms will be used with all 3 octets. The first octet will remain same as 255. Well, we have to understand these 3 terms to be the master of subnetting. I assure you, if you get these 3 terms, you will never feel problem doing subnetting. We will not use any white paper, any calculator for subnetting. Well, just by following these 3 rules, we will become the master of subnetting, inshallah. Well, we will do subnetting without any hesitation, without any problem, with full confidence and without using any calculators, etc. Well, to me, these 3 terms are everything to be the master of subnetting. Well, these 3 terms you can see: rule, block size, bits. First, let's discuss this rule term. Well, we are discussing that each octet consists of 8 bits. Now we used to convert binary values into decimal by calculating them from right to left. Well, we will calculate subnets from left to right. If I say that enable the first bit, so we will enable first bit from left side. Enabling first bit provides 128. We will follow this calculating from left to right as a rule. On each octet we are getting same 8 values. Now I've just show you CIDR range. Let me show you again. Now here it is. Well, we were discussing 4th octet. So with 4th octet, when I enabled first bit from left, we got 128. When I enabled 2 bits from left, we got 192. Then when I enabled 3 bit of 4th octet, we got 224. Here you can see. Then when 4 giving 0.240. While enabling 5 bits from left, we got 248. Well, you can see we are getting same subnets on each octet: 128, 192, 224, 240, 248, 252, 254. Same here, but the position of octet is changed. Here it is 128, 192, 224, 240, 248. Well, you can see, just remembering one point of rule, that here it is 128 is we got 128 by enabling first bit, we are getting 192 by enabling 2 bits, we are getting 224 by enabling 3 bits, and so on. Just remember this rule. Just give a tight glance 2 or 3 times. Just you're going to remember this rule forever and forever. Now we are moving towards discuss block size. Well, for block size, while following our rule of calculating from left to right, when we enable each bit we get a block size. This block size determines how many addresses we are getting by this subnet mask. Well, as you can see that by enabling first bit we get 128 for subnet. We are doing this on 4th octet, so our subnet mask will be 255.255.255.128, and by enabling this first bit we are getting block size of 128. Well, the meaning of this is that we are getting 128 addresses. As you can see, the maximum block size is 128 and we are getting block size of 128 over 128 subnet value. Well, on 192 subnet value, which is in result of enabling 2 bits, we are getting block size of 64. For 224 subnet value we are getting 32, and so on. Well, you can notice that block size is a difference between the value of subnet and the value which is 255. But you will found block size in an even value like 128, 64, 32, 16, etc. You can see these block sizes. You'll find same values of block size on each octet. Well, with this we are almost done. Bit position will determine enable bits, disable bits. Now remember that first octet remains same as 255. Second octet is represented by bits from 9 to 16. Third octet is represented by bits from 17 to 24, and fourth octet is represented by bits from 25 to 32. With this we are almost done. Now we are moving towards another rules. After that we will start our subnetting work. Here it is. Now we have discussed rule, block size, bits. Now for calculating number of hosts we are going to apply this formula. 2 raised to power how many bits we are going to apply for subnets. For example, 1 bit, then we will take that value 1 to the place of n. 2 raised to power 1, it will result in 2, and we will calculate our subnets, number of subnets as with this. Now for calculating number of hosts, this is the formula. 2 raised to power bits we are going to give for our hosts, and then we will minus 2. Why we are deducting 2 from the number of hosts? We'll discuss all this while discussing our work on subnetting. Now let's start subnetting. Here it is. We are starting subnetting process from class C subnets. Now it is class C subnetting. You can say available bits, we have available bits 8. Now I have draw here, you can see rule, block sizes and bits position. Now calculation of number of subnets. Well, this is the formula. 2 raised to power how many bits we are going to apply for subnets, number of subnets. Now For calculating number of hosts, we are going to use the same formula, 2 raised to power how many bits we are going to apply for our host calculation. Minus 2. I'll explain you minus 2 a bit later. Class C subnet mask is, this is default one, 255, 255, 255.0. You can see /24. It means we have 8 bits from 25 to 32. Now we are going to play with these 8 bits. At first, class C subnet mask 1 means I applied 1 bit for subnet. So it results in from left to right, here it is 128. So this is why I applied first bit 255, 255, 255.128. This is our custom subnet. Well, the network we are going to use is 192.168.0.0. For number of subnets, we applied 1 bit for subnet 2 raised to power 1. It results in 2. So for number of hosts, there are how many bits remain from 8? 1 applied for subnet and 7 remains for hosts. Well, to calculate number of hosts, you can see block size we are getting 128, although you can see, but it could be a bit difficult to remember that how many hosts we are getting. Okay, it is easy to calculate. I know now we have got 7 bits, so calculate how many number of hosts we are getting from 7 bits is quite easy by using this handprint. You can see. Well, how we have 7 bits, 3 bits here, 3 bits here, and we'll use 1. These are fingertips. By using fingertips, I used to calculate number of hosts, number of subnets by using my fingertips. Well, with these 3 fingertips, what I'm getting 2 into 2, 4, 4 into 2, 8. Now with these 3 fingertips, I'm getting 8 result. After that, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64, and finally here it is. I am getting 1 fingertip from here. 64 into 2, 70, 128. Now we got 128. How's that? It is as simple as it is. Well, let's calculate again a bit fast. 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64, 64 into 2, 128. So we are getting 128, same result if we see here block size of 128. Now we are getting 128. Now why we are deducting 2 from this 128, I will explain a bit later. Now first we have to draw our subnet mask. We are getting 2 subnet masks for this network. So number one network will be this 192.168.0.0. Well, the other subnet mask will be the difference of block size .0 and .128. So with this difference, we are getting two networks. Well, from these 2 networks, how many hosts we are getting? For each network, we are getting 126 because we have deducted 2, and this is the formula to calculate number of hosts. For this network 192.168.0.0, we are getting this range 192.168.0.1 to 192.168.0.126. This is our available host range. Now we have deducted 2 from this value. Why? Because as you can see here, this is the broadcast range .127, and this IP address cannot be used for as a valid host. This will not, maybe this will function, this will not actually function. Actually this is invalid, this is considered as invalid IP address because this is broadcast range. If you, for example, ping this address range using this subnet mask, etc., so this ping will be pinged to all hosts. We have discussed the function of broadcast in our previous visuals. Now, and the other one, this is, you can see we have deducted two, so one is here and the other one is the next network address. You can see this is the network 192.168.0.128. the address range for this network is from .129 to .2.254. the broadcast address range is .255. Now let's move towards next example for class C subnetting. Here it is. Now we have available bits 8. Calculation of number of subnets, we'll use this formula to raise to power number of bits we are going to give to calculate our valid subnets. Calculation of number of hosts, we'll use this formula. Now this is our default class C subnet mask, and in our previous example we have used 1 bit for our subnet. Now this time I'm going to use 2 bits for subnet. Now this results in .192. as you can see, we are playing with bits from 25 to 30, so this belongs to 4th octet. So at 4th octet you can see .192. so for by enabling 2 bits you can see we are getting 192 subnet mask. Well, we are going to use the same network 192.168.0.0. number of subnets here 2 raised to power 2. Now this time we are getting 4 subnet masks. 2 raised to power 2, we have applied 2 bits so that we can get, we are getting 4 subnet masks. Well, number of hosts, same example, 2 raised to power 6 minus 2. Why minus 2? Because one address is a broadcast address and the second address is the next network. So how many subnets we are getting? We are getting 4 subnets, and how we will get these 4 subnets, we have to look what block size we are getting. We are getting 64 here, so in with the difference of 64 we will apply on this network, we will get 4 subnet masks. So number 1 subnet network, we are getting 192.168.0.0. by applying 64 difference here, we are getting 192.168.0.64. another 64 difference here, we are getting .128, and another we are getting .192. so these are our valid subnets and subnetworks. You can see 4 networks these are. But how many hosts we are getting from 6 bits? We are getting 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32, 32 into 2 64. Same result of block size. You can calculate block size on your fingertips. So we're getting 64 by deducting 2. We're getting 62 hosts for each network. For our network 192.168.0.0, we're getting hosts from point 1 to 62. The broadcast address for this network is 192.168.0.63. For our second network, here it is 192.168.0.64. valid host range is from .65 to .126. broadcast address is .127 and the next network address is 128. For this network, the valid host address range is from 129 to to 190. Broadcast address is for this network is 192.168.0.191. So .192, this is our fourth and last valid subnet mask for this scenario. Valid address range for this network is from 192.168.0.193 to 192.168.0.254. Broadcast address range is for this network 192.168.0.255. Now let's move another example of class C subnetting. For this example, same process, calculation of number of hosts, we're going to use same formula for calculating number of hosts. We are playing with class C subnet mask from bits 25 to 32, and this is our third example of class C subnet mask. But this time I'm going to apply 3 bits for subnets and remaining 5 bits for hosts. So this is the network we are going to use. We are using from the past 2 examples. Number of subnets, by applying 3 bits we are getting 2 into 2, 4, 4 into 2, 8. So we are getting 8 subnet masks for this scenario. And number of hosts, we are getting 2 raised to power 5. How to calculate? You can see here block size 32, but if you wanna calculate it on fingertips, just apply this process: 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, and then finally deduct 2 from this 32 value. You are getting 30 valid hosts for each network, and these are 8 networks. Now we have to draw our valid 8 networks, and our network is 192.168.0.0, and we'll apply the difference of 32 on this subnet, and we will get 8 subnet masks. Now 192.168.0.0 is our first subnet mask. By applying 32 difference of block size at 4th octet, because we are playing with 4th octet, we are getting 192.168.0.32, the second subnet. Well, by applying another 32 difference at 4th octet, we are getting 192.168.0.64. This is our third subnet mask which we have created. This is our 4th subnet mask .96. This is our 5th one, 128, 6th one, 160, 7th 192, and 8th 224. Now for each network, these are our 8 networks, how many valid hosts we are getting from these networks. For this network .0.0, we are getting valid hosts from .1 to .30. Our broadcast address is 31.31, 192.168.0.31. Here it is. Sorry. Now the next network is .32. Here it is, .32. For this network, we have valid address range is from .33 to .62. For this network, the broadcast is 192.168.0.63. So this is our 4th network, 192.168.0.64. For this network, valid addresses are from .65 to .94, and .95, this is the broadcast address. The next network is .96. The valid address range is from .97 to .126. The broadcast address is .127. Now the next network is this is the 5th one, 128. Address range is from 129 to 158, and the broadcast address is .159. The next network is 160. For this network we have host address range is from 161 to 190, and .191 is our broadcast for this network. The next network is 192, 168, 192. For this network the address range is from 193 to 222, and for this network the broadcast address is 223. The next network, the last network for this scenario, is 224. The address range is from 225 to 254. The broadcast is .255. Now we are practicing. We will practice each bit. We'll apply each bit each bit as a subnet mask. We're going through all the examples of class C, class B and class A. So at the end we will feel more comfortable and more confident with subnetting. Well, let's move towards the next example for class C subnetting. Example number 4. In this example we will apply 4 bits for subnets. Here it is, and for applying 4 bits we are getting 16 valid subnets on this address range. Now 2 raised to power 4 means 2 into 2 4, 4 into 2 8, 8 into 2 16. We are getting 16 subnets for this scenario. And how many bits remains, because we are playing with 8 bits from 25 to 32 of 4th octet, so it remains 4 bits for 4 bits. How many hosts we are getting for each network? We are getting 2 raised to power 4. Just use your fingertips. 2 into 2 4, 4 into 2 8, 8 into 2 16, and you can see here this subnet mask is .240 by using 4 bits from left to right. Here it is 240, and it provides 16 block size, and from 16 by deducting 2 we are getting 14 valid hosts for each network. Here it is. Now how many what are our valid subnetworks, because we are subnetting on this network. Now very first network remains same. Here it is. Now we are going to apply the difference of block size, which is 16 on this network. Then we'll get our second subnet for the scenario .16. Again apply 16 difference. Here we are getting 32. Again apply 16 difference. We are getting 48. Again 64, 80, 96, 112, 128, and on 128 apply 16. It is 32 and 44, I think, yes, and then 160 and so on. You can write if you want to. I just draw due to limited view option. Now for this first network, how many hosts we are getting? So we are getting 14 hosts for each subnets. These are valid hosts. So from host 1.1 to 14, these are valid hosts for our first subnetwork. The broadcast address is .15 for this network. The second network is .16. The address range for this network is from .17 to .30, and broadcast address is for this network is .31. The next network is 192.168.0.32. For this network, valid addresses are from .33 to .46. Broadcast address is .47. The next network for this scenario is .48. Valid addresses are range from 49 to 62. These are 14 addresses, and broadcast address is .63. The next subnet mask is subnetwork is .64. For this network, the valid addresses range from 65 to 78 and broadcast address is .79. Let me show you. Here it is, valid address range and broadcast address range for .64 subnetwork. Now the next network is .80. For this network, valid addresses are from .81 to 94 and broadcast address is .95. The next subnetwork is .96. For this network, addresses range from 97. So it is wrong, right? 96 is not valid IP address. It is invalid IP because it is a network. For this network, address range is from .97 to 110. It's okay, it's right. So do not consider this one. .96 is a network. The range is from 97 to 110. Now broadcast address is right, it is 111. Okay, now let's move towards the next network, which is 112. 192.168.0.112. For this network, valid IP addresses range from .113 to 126 and broadcast address is .127. And for this network, 192.168.0.128, addresses range from .129 to 132. 133 would be broadcast address and 129 to 140, 142, 129 to 142. So these are valid IP address range for this network. And for this network, the broadcast address is .143 and next network is 144. So there are few more, so I did not present those networks here because of limited view. You can calculate, it is easy. So it should be, as we are moving towards more examples, and we must feel comfortable. Right now we have much more comfortable with these subnetting. Now let's move another example of class C subnetting. Here it is. Now this is class C subnetting scenario number 5. Now at this scenario, I've applied 5 bits for subnets and remaining 3 bits for hosts. Applying this on this network, for this network I applied 3 bits. As you can see, we are playing with 8 bits from 25 to 32. We are using 5 bits for subnets. In this scenario, by using 5 bits, we are getting 32 valid subnets. How? You can just use your fingertips. 2 into 2 4, 4 into 2 8, 8 into 2 16, 16 into 2 32. So 2 raised to power 5, the result is 32. So how many number of hosts we are getting from 3 bits? We're getting 2 into 2 8, 8, 2 into 2 4, 4 into 2 8, and by deducting 2 we are getting 6 valid host addresses for each subnet, which these subnets are, there are 32 subnets. For each subnet we are getting 6 valid IP addresses for hosts. Now how to draw 32 valid subnets? Now you can see here the block size is 8 and the subnet which we have concluded by applying 5 bits, it is 248. So the difference of 8 will provide us 32 subnets. The first subnet is 192.168.0.0. By applying the difference of 8, we got second subnet, which is 192.168.0.8. Another difference of 8 makes it third subnet mask, which is .16, .24, .32, .40, .48, 56, 64, 72, 80, and so on. So I did not mention all 32 networks because of limited view. You can draw if you want to. I think we are much more comfortable for such with subnetting. So this is why I present you limited subnets out of these 32 subnets. Now for this for this subnetwork 192.168.0.0, valid addresses range is from .1 to .6 and broadcast address is .7. The next network is 192.168.0.8. Valid addresses for this network is from .9 to .14. Broadcast address is .15. The next network is .16. Valid addresses for this network is from .17 to .22. Broadcast address is .23. You can see the next network is 24. For this network, valid addresses range from .25 to .30. Broadcast address is .31. Now the next network is .32. For this network, valid addresses range from .33 to here it is 38. Broadcast address is .39. The next network is .40. For this network, address range is from .41 to 46. Broadcast address for this network is .47. The next network is .48. For this network, valid address range is from .49 to .54. Broadcast address is 55. I am not saying complete address 192.168, just short, you can just recognize easily. Now the next subnetwork is .56. For this subnetwork, the valid address range is from 192.168.0.57 to 192.168.0.62. Broadcast address is 63. Next network is 64. So for this scenario, we are discussing till we have discussed 1 2 3 4 5 6 7 8 subnetworks. There are 32. Due to limited view, I am not presenting you this. You can write these addresses if you want to, although it is easy. You can just recognize easily. You can just calculate these networks and these valid hosts for those networks easily, and subnets also, and broadcasts also. Now let's move towards next example of this class class C subnetting. We have to cover class B and class A also. Now for this example, you can see example number 6. For this example, I am applying 6 bits for subnets and 2 bits for hosts for each subnet. Now as you know, I know that we are playing with 8 bits from 25 to 32. Out of these 8 bits, I am applying 6 bits for subnetworks for this scenario and 2 bits for valid hosts, and we are applying all this on this network. Now by applying 6 bits for subnetworks, it is, I think, wrong answer, 32. Let's calculate 6 by applying 6 bits. How many subnetworks we are getting? We are getting 2 into 2, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32, 32 into 2, 64. We are getting 64 subnetworks, and do not consider this the 32 is wrong answer. We have discussed that 5 bits are giving 32 subnetworks, but 6 bits are giving 64 subnetworks. So usually these are not calculated in much length because of we are discussing CCNA series, so this is why I have to mention all this. Now the right answer for 2 raised to power 6 is 64. 32 is wrong one. Now we're getting 64 subnetworks for this scenario, and we left 2 bits, so we are going to apply 2 bits for hosts. For this we are getting 2 into 2, 4, minus 2. We're getting 2 valid hosts for each of 64 networks. Now why we use such type of networks? It is mostly used networks for wide area networks where only 2 valid hosts are required. Now for those connectivity, we use such type of networks of .255.255.255.252 because we do not waste more. We can use .128.192 for to establish connectivity between wide area networks, but mostly they require only 2 valid hosts. So this is the reason we use such type of network, and it is mostly used .252 networks. These networks are mostly used for wide area networks. So we are going to apply the block size of 4. You can see .252 provides 4 block size, and we have, it is wrong 32, we have 64 valid subnets. So first network is .0 same, apply the difference of 4, which is block size. Second subnet, third subnet .8, sorry, network subnetwork. Okay, now 12.12, .16, .20, .24, .28, .32, .36, 40, 44, 48, 52, 56, 60, 64, 68, and so on. There are 64 subnetworks. Now for all of these networks, the host range is from, you can see, .1 to .2. Broadcast address we are getting for this network is 192.168.0.3 and so on. I think we can calculate all the valid IP addresses for this network, for this scenario actually. Now we have almost done with class C subnetting. We have applied 6 bits for this scenario, and this is the last scenario for class C subnetting, because if we apply 7 bits for subnets, then we are not going to get a range of addresses to build the network for hosts. So this is the reason actually this is considered as last example for class C subnetting. Now a bit tougher, class B subnetting. Here available bits are 16, so we are going to play with 16 bits from 17 to 32, and same formula to calculate the number of subnets, 2 raised to power 2. How many subnets we're going to apply for these coming scenarios, number of hosts, same formula. Class B subnet mask is 255.255.0.0. Now class B subnet mask 1, I applied 1 subnet mask, 1 bit for subnet mask, and we're getting 255.255.128.0. Now we are going to apply on this network all this process. So how many subnets we are getting? We're getting number of subnets is 2. For now the difficult one, for hosts there are 15 bits. Usually we do not use such long bits for hosts to calculate manually. Usually we calculate on class C subnetting but although we are studying a whole CCNA course, so we have to we have to we have to play with all these bits. Now there are 15 bits, you can see. So the result of 15 bits is 32768 minus 2. So each subnet provides 32,766 valid hosts for each subnet. Now our first subnetwork is 172.16.0.0 and apply the difference of 128. Now the important point is here. This is the point where we make mistakes. Now in our previous presentations of subnetting, we were playing with fourth octet. Now the process is same. We apply one bit for subnetworking. This is 128, and the important question is the third octet, because we are playing with class B subnet mask. So you can see the point. The difference of 128, the block size, will be applied on third octet. You can see .0 and .128. So these are two valid subnets. For the first subnet, this subnetwork, the valid host address range is from 172.16.0.1 to 172.16.128.254. you can see, and .255 172.16.127.255 is the broadcast, and 172.16.128.0, this is the next subnetwork. For this network, valid host range is from 172.16.128.1 to 172.16.255.254, and the broadcast address range is 172.16.255.255. So the important point is just not the position of octet. We are playing with class B subnet masks, so we have to apply our subnetworking on third octet. So this is the point where we do mistake. So we have to focus, we have to confident for these areas. Now let's move towards the second example for class B subnet. Now the default subnet is 255.255.0.0. Now this time I'm going to apply 2 bits for subnets, and by applying 2 bits for third octet, just note the point, third octet, we are getting 255.192.2. For 192, the block size is 64. It means we are getting 4. You can see 4 subnetworks with the difference of with the difference of 64 on third octet, you can see. So these are valid for subnets. Now remaining number of bits are 14. Now we have 14 bits for valid hosts. Now we have 4 subnetworks. For each subnetwork we are going to have 2 raised to power 14 minus 2, 16384 minus 2 is equal to 16382. We are getting 16382 hosts for each of these 4 networks. Now for first network 772.16.0.0, host range from 172.16.0.1 to 172.16.63.254. Here the point. So these are valid addresses for this network, and the broadcast address is 172.16.63.255. Although subnetting is very easy, what we mistake regarding this subject subnetting is we miss the right octet. So the next network is 172.16.64.0. For this network, valid addresses range from 172.16.64.1 to 127.254, and the broadcast address is 172.16.127.255. Next network is 172.16.128.0. For this network, addresses ranges from 128.1 to 191.254, and broadcast address is 191.255. and the next and final subnetwork for this scenario is 172.16.192.0. for this subnetwork, valid addresses are from 192.1 to 255.254. Broadcast address is 172.16.255.255. Let's move another example of class B subnetting. This is the example number 3, and in this example I'm going to apply 3 bits on this subnet and on this network, getting 8 number of subnets. Remaining bits are 13, so we are going to apply 13 bits for valid hosts and getting 2 raised to power 13 minus 2, 8192 minus 2 is equal to 8190. So we are getting 8190 hosts for 8 subnetworks each. So for this class B subnet mask, you can see 224. The block size is 32. So just apply the difference of 32 on this network till you get 8 subnetworks, starting from 172.16.0.0. The second subnetwork is 16.32.0, 16.64.0, 16.96.0, 16.128.0, 160.0, 192.0, 224.0. Now, valid addresses for our first subnetwork ranges from 172.16.0.1 to 172.16.31.254, and the broadcast address is 172.16.31.255. Next subnetwork is 172.16.32.0. For this network, valid addresses are from .32.1 to .63.254. The broadcast address is .63.255. Next subnetwork is 64. For this subnetwork, address range is from 64 to 95, and I think the address range is missing. Yes, address range is missing. For third subnetwork, address range is missing. So for this network, 172.16.64.0, valid addresses range from .64.1 to 95.254, and broadcast address is 192.16 192.95.255, and the address is missing, another the whole process is repeated here, so do not consider this one. And the next network is 172.16.96.0 addresses. Valid addresses range from .1 .96.1 to .127.254. Now broadcast address for this network is 172.16.127.254. Now next network is 172.16.128.0. Valid addresses for this network is from, it is not mentioned here in the list on the right side, these are repeated again, so do not consider these address range. Now for this network 172.16.128.0 addresses range from 128.1 to 159.54. These are the valid addresses for this network, and the broadcast address is 172.16.159.255. For this network addresses, valid addresses are from .160.1 to 191.254, and broadcast address is 172.16.191.255. Now let's move towards this network. Valid addresses for this network is from 172.16.192.1 to 172.16.223.254. Now broadcast address is 172.16.223.255. So this is the final subnetwork. For this network, addresses range from 172.16.224.1 to 172.16.255.254, and broadcast address is 172.16.255.255. So with this we have done our this presentation, this scenario. Now let's move towards another scenario of class B subnetting. In this scenario I'm going to apply 4 bits for subnetworking and for subnets, and remaining 12 bits for hosts. So by applying 4 bits for on this network, we are getting 16 valid subnetworks, and for 1 2 3 4 16 we're getting block size of 16. So with the difference of 16 we are getting 16 subnetworks for this network. Here it is .0.0.16.0 32 48 64 80 96 112 128 and so on. Now we have to mention valid IP addresses for these networks. So number of hosts, we have 12 available bits for number of hosts. So by 12 bits we are getting 4094 hosts for each of this subnetwork. Now for this network, valid hosts ranges from .1 to .172.16.0.1 to 172.16.15.254. Broadcast address is 172.16.15.255. Second subnetwork is .16.16.0. For this network, valid addresses are from .16.1 to .31.254. Broadcast address is .31.254. Next network is .32.0. For this network, we are getting valid addresses from .32.1.47.254. Broadcast address is .47.255. Now next network is 48.0. For this network, valid addresses are from .48.1 to .63.254. Broadcast address is .63.255. Now the next subnetwork is .64. For this network, addresses are from .64.1 to .79.254. Broadcast address is .79.255. So next network is subnetwork is 172.16.80.0. addresses valid addresses for this network is from .80.1 to .95.254. broadcast address is to 172.16.95.255. next subnetwork is 172.16.96.1. This is the first address. This is the valid address range starts from 2.111.254 for 172.16.96.0 network. Broadcast address for this network is 172.16.111.255 and network 172.16.112.0. valid addresses for this network is from .112.1 to .127.254. broadcast address is .127 and 255 and so on. So you can just calculate valid addresses of upcoming subnetworks. Now we are moving towards another example of class B subnetting. The example number 5. For this time I'm going to apply 5 bits for networks, for subnetworks. By applying 5 bits we are getting 32 valid subnetworks and remaining 11 bits for hosts providing us 2046 valid hosts for each subnet. Now for 5 bits we are getting block size of 8. So with the difference of 8 on this network we are getting 32 subnetwork starting from 172.16.0.0, .16.8.0, 16.16, 16.24, 32, 40. Just see the octet number, it is third octet. 48, 56, 64, 72, 80, 88 and 96, etc., etc., so on. For our first subnet, valid addresses are from .0.1 to .7.254. broadcast address is .7.255. For our second subnet, addresses valid addresses are from .8.1 to .15.254. broadcast address is .15.255. For our third subnetwork, for this scenario, valid addresses are from .16.1 to .23.254. broadcast address is .23.255. For our next subnetwork, addresses valid addresses are from .24.1 to .31.254. broadcast address is .31.255. For valid addresses for 172.16.32.0 are from 32.1 to 39.254. broadcast address is .39.255. valid addresses for .40.0 network are from .40.1 to .47.254. broadcast address is .47.255. For networks 172.16.48.0, addresses, valid addresses are from .48.1 to .55.254. Broadcast address is 255.255, 172.16.55.255. Now this is broadcast address. Now valid addresses from 172.16.56.0 are from 172.16.56.1 to 16.63.254. Broadcast address is 172.16.63.255. I think we are much more comfortable to calculate valid host, to calculate subnets and valid hosts, but we have to go through some more examples. So let's move towards another example of class B subnetting. For this scenario, I'm going to apply 6 bits for subnetworks. This gives subnet mask like this: 255.255.252.0. So while using 6 bits, I'm getting block size of 4. So I'm going to apply 4 block size on this. So by applying 6 bits for this scenario, we are getting 64 valid subnetworks, and the difference of 4 I'm going to apply on this till I got 64 valid subnetworks. So these are valid subnetworks. So I think we are much more comfortable with all these. The number of hosts which we are going to get, just use your fingertips to calculate. For 10 bits we are getting 1022 valid hosts for each of 64 networks. For first network, we are getting IP addresses from .0.1 to .3.254. Broadcast address is .16.3.255. I think I am not going to spend my time here because we are much more comfortable with all these calculations, and if you want to do, you can just pause the video here and you can do it. Although I think you are also much more comfortable with all this. Now let's move another examples. We have to cover a lot of examples till yet. Now this is the example number 7 for class B subnet mask. Here I'm going to apply 7 bits for subnetworks. This gives me subnet mask like this: 255.255.254. So for this subnet, by applying 7 bits, I'm getting 128 valid subnetworks here for this scenario, and remaining 9 bits gives remaining 9 bits I'm going to apply 9 bits for hosts. So 9 bits giving me 510 valid hosts for each of 128 subnetworks. Now this is 7 bits, so 7 bits providing the block size of 2. So this is the difference which I am going to apply on this network till I get 128 subnetworks. 172.16.0.2.0, 172.16.2.0, 4, 6, 8. Look at the octet number. It is third octet: 8, 10, 12, 14, 16, 18, 20, 22, and so on. So here I am also not going to calculate all this. I think we are much more comfortable. Let's move another example of, you can pause the video here if you want to calculate all these valid hosts and for all these subnetworks. So this is the final example for class B subnetting. In this example, we finally got the default C subnet mask. Now by applying 8 bits, we got subnet mask like this: 255.255.255.0. It provides 256 subnet masks, and each subnet mask providing 254 valid hosts. So by applying the difference of one here, because we are using 8 bits on this network till we got 256 networks starting from .0.0. So again I'm missing the calculation step of calculating host for these network. If you want to, you can pause the video here. Now let's move towards class A subnetting. Now here we have 24 bits. Formulas are same. Class A subnet mask is 255.0.0.0. Now here I'm going to apply bit 1 and just note the octet number. It is octet number 2. So we're going to apply on this network 10.0.0.0. Number of subnet is provides 2 number of subnets, and by using first bit we got 128. So the difference of 128 on this network gives me 2 subnets and not the octet number. It is second octet because we are playing with class A subnets. So here I am going to mention 128 on second octet. So these are 2 valid subnetworks for this subnet. So at this stage we have 23 bits for valid hosts. So apply these valid by using these 23 bits we are going to have 8388606 valid hosts for each of these networks, these 2 networks. So this is where from 10.0.0.1 to 10.127.255.254. so these are valid IP address range for this network. Broadcast address for the first subnetwork is 10.127.255.255. For second subnetwork, just note the octet number. It is second octet. So valid hosts are from 10.128.0.1 to 10.255.255.254, and broadcast address is 10.255.255.255. Now let's move towards another example of class A subnetting. Here I'm going to apply 2 bits for subnets and remaining 22 bits for valid hosts. So we're getting 4 subnets. So with the difference of 64, applying on this network provides 4 networks. You can see each network providing 419.1302 hosts. So for this network 10.0.0.0 valid hosts are from 10.0.0.1 to 10.63.255.254. broadcast address is 0.63.255.255. for second subnetwork addresses are from valid addresses actually are from 10.64.0.1 to 10.27.255.254. just note the octet number. It is second octet on which we are playing. Broadcast address is 10.127.255.255. For third subnetwork addresses are from 10.128.0.1 to 10.191.255.254. broadcast address is 191.255.255. For final subnet of this scenario is for final subnetwork addresses, valid addresses are from 10.192.0.1 to 10.255.255.254. broadcast address for this subnetwork is 10.255.255.255. Now let's move another example of class A subnetting. Here it is. Here I'm going to apply 3 bits for subnetworks. So we are getting 8 number of subnets by using 3 bits, 8. So 3 bits providing us the difference of 32. By using the difference of 32 on this network, it is giving me 8 subnets. You can see here 8 subnets. Each subnet work is giving me host number are 2097150. So for this network, valid addresses are from these are the valid addresses for this network. Broadcast address is this for this network, and rest of the calculations is in front of you. I'm just leaving the process of calculating valid host. I think we are much more comfortable with all this process. Let's move another example of class A subnet. Here I'm going to use 4 bits for subnetworks. Gives me 255.240.0.0 subnet mask, giving me 16 valid subnetworks. Using the difference of 16 on this network provides 16 network. You can see number of hosts. Each network is providing 1048574 number of hosts. So again, I am just leaving the process of calculating valid hosts for these available subnets, because I think we are much more comfortable with all this. Let's move another example. Here it is. In this example, I'm going to apply 5 bits for subnets, and it gives me 255.258.0.0 subnet mask. By using 5 bits for subnets, I'm getting 32 subnetworks. Remaining 19 bits giving 52, 42, 86 hosts for each subnet mask of these 32. Now 5 bits giving me the block size of 8. So with the difference of 8 on this network, I'm getting 32 valid subnetworks actually. Now again, you can pause the video here if you want to calculate valid host, because I think we are much more comfortable with all these calculations. I'm just moving towards examples. It is example number 6 for class A subnetting. Here I am using 6 bits for subnetworks, 6 bits providing 64 subnetworks, and each subnetwork is providing 262142 valid hosts. So with the difference of 4, you can see I'm getting 64 subnetworks on this network. Now it is .0.4.8.12 first subnetwork, providing valid addresses ranges from 10.0.0.1 to 10.3.255.254. Broadcast address for this network is 10.3.255.255, and so on. You can carry on your calculations if you want to, if you feel uncomfortable, but I think we are much more comfortable and we are much more confident on calculating valid IP addresses. Let's move another example of class A subnet. Here I am going to use 7 bits for subnets, providing 128 valid subnets, each subnet providing 131070 hosts. With the difference of 2 on this network, I am getting 128 subnets. Here you can see. Rest of the calculations are same. Let's move another example, and this is the final one. Here I am going to use 8 bits on class A subnet. Now it's giving the default subnet for class B. Well, by using 8 bits, it is providing 128 subnet masks. Some wrong calculations here. By using 8 bits, we are getting not 128 subnets, we are getting 256 subnets. So by using 8 bits with the difference of 1 on this network, we are getting 256 subnetwork. Just do not consider 128 here, just correct these mistakes. Sorry for these mistakes. So it is 256 number of subnets we are getting. So each subnetwork is providing 65,534 valid hosts. Rest of the calculations are same, and with this I am concluding this very long visuals. In this we have almost covered, we gone through all, we use all bits for subnets and for valid hosts. So if you feel any problem, you can just replay these visuals and be prepared for upcoming visuals. Thank you.